Hello class, today's tutorial will be on calculating the enthalpy change of a reaction. This is another tutorial in topic 5 on energetics and thermochemistry. The enthalpy change of a reaction can be calculated by totaling the enthalpies of formation of the products and subtracting them from the enthalpy of formation of the reactants. What's important to remember in these problems is that elements have an enthalpy of formation of 0. The enthalpy of formation is always multiplied by its coefficient in the balanced chemical equation. And remember that the coefficient is equal to the number of moles, N. So the formula looks like this. The change in enthalpy of a reaction is equal to the sum of all the enthalpy of formations of the products minus the sum of the enthalpy of formation of the reactants. And notice that these change in enthalpies of formation are multiplied by the number of moles. So we're going to practice with this equation. 2 moles of H2O2 hydrogen peroxide are decomposed into 2 moles of water and 1 mole of oxygen. So what is the enthalpy of formation of this particular reaction? So first, we're going to look up, and I have posted this in the folder under topic 5. We're going to look up the enthalpies of formation of each of the reactants and then each of the products. So we'll start with our reactants, since that's first right here. We'll start with our products because that's first. So we want to know the sum of the enthalpies of the products. Now notice I have 2 moles of water, so I'm going to be multiplying the enthalpy formation of liquid water, which is negative 285.80 kilojoules. And then I'm going to add it, because this is a sum. Actually, no, I have to the enthalpy of formation of oxygen. Now, oxygen is an element, so its enthalpy of formation will be 0. Then I'm going to subtract the sum of the enthalpy of formation of the reactants. And so this case, I have 2 moles of H2O2, and the enthalpy of formation of H2O2 is negative 187.8 kilojoules. So when I multiply this, I get negative 571.66 kilojoules minus negative, bracket these, minus negative 376.6 kilojoules. I'm keeping my eye on my sig figs as I'm doing this, multiplying and subtracting gets a little bit tricky, and so I notice that I have negative 196.06 kilojoules. And so it looks like I have 2 decimal places here and 1 decimal place here. So it looks like I'm going to maintain 1 decimal place. Let me double check to see if that's right. Yep, I'm going to maintain 1 decimal place. So the answer will be negative 196.1 kilojoules. So the enthalpy of the reaction is equal to this. So it looks like we're going to have an exothermic reaction, and if I wanted to add that to my equation, I would add it on the product side. So I'd add 196.1 kilojoules. And notice it's not per mole because I am decomposing 2 moles of H2O2.